public domain.
Presentation on continuous delivery with the Jenkins pipelines and Blue Ocean. So just before we start, I wanted to know, does anybody use Jenkins in the room? Okay, so a few times, and anybody has done just continuous integration with any other tools at all? Okay. It kind of follows on very nicely with the previous presentation. In fact, there's a lot of overlap, so my bit's going to be very short. Okay. So yeah, it's up to him to convince you guys otherwise. So we are Vertex Limited. Basically, it's me and Sreeji. We are the owners. So here, Sreeji is a CLA, CTA, I'm a CLA, CTD, and we do all sorts of stuff with a lot of alliance partners too. So there's not much to say there. A couple of caveats before we start. So there is some amount of coding involved with Jenkins. I'm sure some of you are aware. So, and we are hoping the demo gods are with us. So the last time we did this, it didn't go as planned. So yeah, we're praying. So that's how that is. Agenda is a quick introduction. Like I said, it will be a short introduction because it follows on from the previous one. And then Sreeji is going to take you through the CI tools and the pipeline as code and with the demo at the end. So just to give a brief, very brief overview. So software engineering, you plan, you design, so you use human tools. And you develop with whatever tools you want, then you validate, you run unit tests, do your reviews, and then you deploy. So very straightforward process. Sometimes from planning to delivery can take a very long time. Sometimes if you do it right, it can be a very efficient process. So some of the resources you can use for agile working approach, it's been talked about many times by different people, so I'm not going to go in detail there. So yeah, this is our normal way of working. So you have source code, so you have a master branch, and then you branch off if you want to do bug fixes or if you want to produce new features, and then you merge them. So again, it's a fairly simple process, but it can cause you headaches if you don't do it right. So continuous integration, the idea of continuous integration is, in the olden days, especially with the waterfall model, people used to plan, develop, and there used to be a big period dedicated to do integration. And that's when you started finding all the issues and the bugs and the problems with merging. The idea of continuous integration is as soon as you make a change, you integrate immediately. So you know that if there are any issues, you find out as soon as the code is developed, rather than leaving it to a later stage. So this is by Martin Fowler. So he's basically quoted that. That's what you do automatic builds and you do multiple integrations per day. So why, again, like I said, you detect faults early, and then any alerts on the fail itself are again automatically notified by emails. So you avoid human errors. So there's no more things like, okay, it works on my machine, but then I deployed it to a rig that actually runs the test, but it doesn't work. So we don't do things like that. So it frees up the developers to actually do the coding bit rather than focusing on trying to merge code and trying to run tests. So again, standard process. So if the build process is automated, then you don't have to teach everybody how to do it. So they only need to know how to develop the code and deliver it, and then the build happens in the background. And this obviously promotes more testing. So, and again, machines never forget to perform a particular action. Human errors, oh, I forgot to click that button, or I forgot to test that, I forgot that step in the process, so that doesn't happen. So when it comes to continuous integration, you can do it in different stages. So just the integration, so you build and test, or you do continuous delivery. So you build, test, and you deploy to a staging area, and then you run automated test. So the actual deploying to production becomes a manual process. You then take the package and deploy it manually. Sorry, or you do the whole thing, which is what we are focusing on is continuous integration and continuous delivery, which is you build, test, and you release it to production at the same time. So various different CI servers. Again, Sumedha and Eric covered some of them earlier. So this is where I hand over to Sreeji. So he's going to take over, talk about Jenkins.
Thank you. Hi, I'm Sri. As you can see, we've got multiple options as far as CI is concerned. We used to first work with TeamCity, and TeamCity used to work well for us, but then Jenkins came out with the pipeline feature, which is also in TeamCity as well, but we found that the Jenkins pipeline was much more flexible, and it had a lot more support. So we migrated over to Jenkins recently, and other ones are available. But the main thing is Jenkins is free, and we like free. Again, I don't need to tell you, Jenkins obviously is free, as I said, and it supports multiple source code control platforms, so like Git, Mercurial, Perforce, and so on and so forth. And obviously, like any other CI tool, you can build your code on multiple triggers. So that could be a periodic trigger or based on holding the source code controller, source code control. And Jenkins pipelines now integrate very well with Git and Bitbucket, which means that the polling is not required. There's an automatic link commit, which means that every time you push something, it detects it once the thing, as long as you've configured to do so. Jenkins obviously on its own is kind of useless, but there are plugins which enable or gives it the magic, if you like. For our implementation here, these are the plugins that are required. So there's a link. So I'm going to release this presentation at the end of to the community. So the link basically refers to a decaf build system that was done by the NI Systems Engineering Group, and they've done an incredible job. So Rita, one of the product managers here, so at the back, so if you need to speak to anybody in the systems engineering, so I'm using a toolkit released by the systems engineering group, and it is awesome. They've done most of the hard work for you. Adopting this should be really easy. So as I said, I sat in a presentation by Roxana and Matt Pollock last year during an I week, and they presented an implementation of a pipeline. It was still a bit difficult to pick that up, but then since then, Jenkins has released something called Declarative pipelines, which basically focuses on a limited number of keywords and sets, which focuses on simplicity than full code coverage. What you can achieve with the full pipeline implementation. So I'll go through the limitations and also what we can achieve with the declarative pipeline, which I think is pretty easy and well thought out. So, the title of the presentation said Blue Ocean and continuous and pipeline. So what is Blue Ocean? So if you've worked with Jenkins, you would know this GUI. It looks pretty outdated as far as I'm concerned. CloudBees, who maintain Jenkins, so they have an enterprise version of the Jenkins as well. But they also work on the open source bit. So they came up with Blue Ocean. So it's a plugin again, which looks a lot more modern, and it allows you to do most things. So it's still being worked on, but I think this is more suited towards the pipeline implementation. So if I jump back to the presentation, if it works. Yeah. So Blue Ocean redefined user interface, as I say, and designed ground up for pipelines, but also works with traditional or classic jobs, or freestyle jobs, as it's called. The thing that I'm most impressed by is a pipeline editor, or what we should be impressed by is a pipeline editor which is graphical. So we all like graphical. So this allows you to define your pipeline using a graphical tool. So as you can see, you can have parallel stages running, and also define your pipeline as using this graphical tool. And also, you can have better visualizations than what is already available with Jenkins currently. So it allows you to then sort of see what your test or the current run looked like. So I'm just going to jump to the demo part, and this is when I keep my fingers crossed. So you click on a new pipeline, as you saw, and okay, one more caveat: Perforce is not supported yet. SVN is not supported yet. Bitbucket and GitHub and Git, if you're using that, then you're wrong. So this will make it much more easier. That doesn't mean that pipelines can't be used with Perforce. It can be. Please come and speak to me if you need to implement it that way. So what you do is choose your source code control. So if you've not registered with this user interface before, it will ask for a username and a password. Or for GitHub, it will be an API key. You enter the API key. It lists the projects that or repositories that are in your organization, and then when you click that, then it will list all the projects. It then lets you select the projects, and you go click Create Pipeline, and it says completed. And it starts to run it. But obviously this is empty, so it doesn't do anything, but there's an edit button, so that allows you to, okay, sorry, it is not empty, I've done something to it. But so the configure step, basically, and the test step are already there. So if I want to add a step, I click on the plus, name the stage to say analyze or something like that. And you click on add step, and the add step lists all the Blue Ocean plugins support, or Blue Ocean methods supported by the plugins that you've installed. So by default, obviously, you have like print message, Windows batch script, and also a shell script for Linux systems and stuff like that. So in this case, I'm just going to do a print message, and then click. So you go on, and also you can then add a parallel stage. Which says. So that could be a unit test and analysis working on the same, or running parallelly. So, for example, if I don't define a step in my stage, it then tells me that there is a problem. So with this icon, so it needs to know that there is at least one step inside my stage. So that would be. Okay. So this is how you can build your skeleton pipeline, if you like. So obviously, you're saying, okay, yeah, this is well and good. Where is the LabVIEW bit? So anyway, so if I press Control S on this, it then goes back into a pipeline script editor, which is the code that is generated behind for you. So once, you can make changes here if you want to. If not, you can then click on Save, and then it will save and commit to your source code control. What you can also define are environment variables. And so these are variables that will be used within your pipeline, and also you can have per stage environment variables. So in here, if you click on this particular stage and settings, then you can add an environment or a state-specific environment variable, you can also have a state-specific agent. I mean, so there may be an agent that will, or you may want to run a particular stage on a LabVIEW UTF machine or one which has FPGA installed or something like that. And that can be specified using labels when you define your agents. So there's a link at the end of the project or the presentation which shows you, again, it takes back to the systems engineering group. I mean, they've done a tutorial as to how you set up your system CI, and that shows you how to build Windows agents. And then for each Windows agent, you can have multiple labels. I mean, so that could say LabVIEW test and FPGA real time. I mean, so you can, based on the labels, assign to say that, okay, I want to run this particular stage in this on this agent.
Sri, I think you said that I didn't entirely catch it. So once you've got this set up, that this UI will save that back to your
CI. Yep. So you can either start with a blank sheet and not have something, or you can have a Jenkins file in the root folder of your project, and then it will pick that up. So if there's one already. So in this case, I'll just go save, and you can either come into the master branch or say, okay, I want to come into a new branch. So I'm not going to do this for now. So if I switch back to the presentation. So yeah, so that's Blue and as I say, the visual editor and the code behind it. Declarative pipelines, and as I said, the code that it generates pretty much acts as the skeleton you want to. So in this case here, I've got a batch command which says, okay, make a directory, build temp. So most of the time, I've spent a lot of time trying to debug some of the issues that I introduce into a pipeline file, and that's because of quotes and single quotes and escaping characters. But as such, the mechanism behind it is pretty solid. And there are ways to sort of debug things, and I'll go into that. So this is a typical pipeline script. Okay, there. And so like what James said before, I don't get time to do an analyzer test, for example. So all you need to then do is create a configuration file showing what the analyzer test you need to run and specify using a call to the analyzer. So for example, in here, for the unit test, all I'm doing is calling a function UTF and then providing it a path to the unit test framework project file, and then the version of the LabVIEW that I want to run it on. So I went through demo one already. Pipelines. So Eric and Sumaila did a good job of explaining these things, so I don't really have to do this again. But basically, there are stages. So it is what happens between your push and production, as in push of your source code. And so the main thing here that I want to stress about is that Jenkins pipelines use Groovy scripts. So Groovy, I will explain what Groovy is in a second if you're not familiar with it. And also multi-branch pipeline. So if you have a main line and if you have multiple branches in it, you can have multiple Jenkins files in each of the branches, and they can all do different things if you want to. So pipeline as code, again, Eric touched on this. Previously when it was freestyle jobs, your configuration of your source code or your CI was in a server, and if the server crashed or if something went wrong with it, going back to your CI setup was a lot of effort. But whereas this configuration lives as part of your source code, and you can even version them. So if you made a change to the Jenkins file which broke something, you can always revert back. It lives with your source code, and it doesn't then require a lot of effort to bring back to your previous setup. So as I said, Groovy is a programming language for the Java platform. E is object-oriented, this and the other. So Jenkins uses Ruby scripts. And I've already showed you what the scripts look like. So again, the systems engineering group created a toolkit which gives us a set of shared libraries, or a shared library which has multiple functions or methods that we can call from within our pipeline. And it's available as a VI package. So I have a link of that for that at the end of the presentation. So you just have to install it, follow that tutorial, and your system is set up. And then it's only down to you to do the Jenkins file. That should be easy enough to do, as far as I'm concerned. So also write the test, obviously. So why use shared libraries? So shared libraries obviously do the heavy lifting for you in the background. And if you always do a process, make a shared library of that, it's pretty easy to do. And all you need to do, again, the shared libraries live in source code control as well. So you link your shared libraries, or you tell Jenkins that this is where my shared libraries are. And every time you run a pipeline, it gets picked up, and all you then need to do is to call it. And also, because the shared libraries then do the heavy lifting for you, you can push this out to everybody. So your CLAs, CLDs, regardless of what their capabilities. All they have to do is maintain a Jenkins file, call the right calls, give it the right path. Okay, so LabVIEW exit code, and for people from outside the United Kingdom, so we're going through Brexit, so anyway, so obviously LabVIEW doesn't have an exit code mechanism or a standard out mechanism. This problem is solved by James here, so thanks for that. And so we're using his CLI tool to realize this. So obviously, as I said, LabVIEW can take CLI arguments, but standard in and standard out is not possible. LV exit, or LabVIEW exit, the solution, so what James has done is, so he's created a C# executable which communicates using the ISO TCP port, and you can then pass the arguments, and then he creates a standard output with an exit code. So this has been talked about already in the previous presentation. So Eli Carey, who I think maybe here. No, he's not. Okay. So anyway, so he has a blog, and in the blog he's sort of mentioned about what is coming in 2018, and there's already a beta version available for you to try out if you want to. So the link is there, and so it will ship with 2018 is what I'm told, and also it is backward compatible to 2014. They also provide a set of VIs, which is a class-based system. Which means that you can override it with your own set of common functionality. So requirements. So for us to. So your question about how do I make this for LabVIEW? So obviously, the unit test framework does not output the results in JUnit format, which needs to be converted. So there is a toolkit again available. And for the JKRVI tester, there's a package available, and so on and so forth. These are the packages that we need to install. So I will go into a little bit of Python fundamentals. This is a little bit of code, I'm sorry, but anyway. So what does your pipeline look like? So pipeline has a pipeline keyword which encompasses everything within your pipeline code. And after that, you then have to specify which agent you want to run it on. In this case, can run on any agent. But like I said, I mean, it can run based on a label or a Docker container or anything of that sort. So, as I said, agent can be anything. It can be, there is a none, I have no idea why, but well, it could be because it can run on the master. I mean, so on the server itself, I have no idea, but I've never used it. But are based on a label or a Docker container, as I said.
I think the main use that I'm planning to try with that is if you've got a toolkit and you want to support, say like 2011, 2013, 2015, you can just build a different agent for 2011, 13, 15 and push it out to each of those. And you know they're being built in an isolated environment without influence from the newer versions. That's the biggest use I can see in LabVIEW for doing that.
I mean, I'm talking about the none keyword as to, I mean, it doesn't want to be run on any.
Sorry.
So I don't understand that, but anyway, I mean, so. But labels, I agree. I mean, so it could be specific to a software. I mean, so in one case, you may be building a DLL, and your machine, one of the agents has a C++ implementation or installation maybe, and so you can then say that it needs to run on that, and so on and so forth. Okay, so post. This is important. I mean, so in textual programming, I mean, so we've got try-catch mechanisms. I mean, so if something fails, you want to be able to catch and do something with it. So what Jenkins provides, or pipelines provide, if I can get rid of this, is a post keyword. And within post, you can then say, okay, I've got an always, which is, it will always execute. I mean, for example, at the end of the pipeline, if you always want to delete your the files that you checked out, then you can put it there. And if it's a success, then you put it in a success. If it's unstable, which means that I think it's less than 30% or something, or let's say 70% success rate, then it's classed as an unstable build. And a failure obviously is a failure, and you can then send an email to the person or the developer saying, you broke the build. We have a very rude picture that gets attached as well when that goes. And changed is when the state of your build changed. I mean, so from pass to fail or fail to pass, I mean, to, sorry.
Yeah, just having an image or an email, it's better than having one of the team members coming and telling you.
Yes, yes.
Who doesn't feel. So just want to point that out.
And so, yeah, if it's aborted, then obviously that leads to an aborted thing. So this is instead of a try-catch mechanism, I mean, and this can be for your overall pipeline or per stage again. I mean, so for example, if there's a unit test, I mean, that you want to run, and then for that you want to catch the results and archive it or convert it to J&J, and then you put it in the failures or in the success section or something like that. So, as I said, I mean, pipeline has stages, I mean, so which shows multiple stages within your pipeline, and each stage has to have a name and multiple steps in that. And so I'm going to stop here talking about syntax, or maybe I need to tell you about environment as well. So environment basically, as I said, are name value pairs or key value pairs, if you like. And it allows you to define key value pairs for each of the stage or for the overall pipeline. What it also does is that, I mean, so when you sign up to Bitbucket or Git or something like that, I mean, so if you provided a username and a password to Jenkins, it allows you to get credentials from that. So, so instead of having to provide your credentials in your pipeline, you can then say, I want to use the credentials that I provided to this particular platform, and then use that to in your pipeline, which makes it really powerful. So as well, I mean, okay. So now if I switch back to so here I have a Jenkins demo project. So it's pretty blank, as you can see. Sorry about this. So Jenkins file can be edited using your standard text file if you want to. I mean, but GitHub has something called an atom editor, which is free, obviously, and it recognizes Jenkins file as a Jenkins file. There's a plugin. Sorry, this is not a Jenkins file. Sorry. There. So as you can see in the bottom corner here, it's a Jenkins file, and it then highlights your keywords and stuff like that, which makes it slightly more easier to define. So in this case, I mean, so what we're going to do is to add the unit test framework call. And so my project is simple. It just has a couple of build specifications and a unit test, some unit tests written to it. And all I have to then do is define the project path. And so in this case here, which is relative to my Jenkins file. So in LabVIEW folder and then generic. And as I said, I mean, a lot of the time I've been caught out by not escaping the right things and also quotes and that kind of thing. And so, so if you look at the implementation, so it is a UTF. So the name of the function is a UTF test. I mean, so, and this is contained in the shared library released by the systems group. So if you look at the UTF, can everybody see this? Yeah. So it has a definition and a call with two parameters. I mean, so which is what you're specifying in your Jenkins file, and this is, I mean, basically about calling a batch file, and then James's CLI command with the right parameters in it, and at the end of it, it then uses the JUnit plugin to convert your results in. To XML, from XML, so that Jenkins can recognize it. So there are multiple files. I mean, so for example, this is the LV build file, which takes target name and the specification name, the version of the LabVIEW again. So if I go back to my Jenkins demo, how much time have I got? Around 12 minutes. Okay. So I talked about multi-branch pipelines. I mean, so this is my Jenkins demo, which is hosted on Bitbucket. There are two branches in it, and one of them is the default one, and the other is the demo branch. So if I click on run, it starts to run, and it automatically checks out your code. I mean, so you don't have to specifically say in your pipeline, check out the code. I mean, because you specified the Jenkins file, it knows where to check it out from. One caveat is that if in Jenkins file you also specify your triggers and your polling mechanisms and things like that, but Jenkins does not know about this. So you have to first run it manually so that it then knows what to do the next time. So in this case, it's running the UTF test. It's a simple Mickey Mouse test, but it does, for a demo, I think this is good enough. So it's run that, and now going to the build, in which builds the, so again, brings up LabVIEW, runs its building of 2 PPLs, and then in the end, it then goes on to build packages. I mean, so using VIPM. I mean, obviously VIPM package building requires VIPM professional license. Jenkins in PPL. I will go through the code in a second, so I'm not making this up, it's not recorded.
So is that multi-branch a special project type, or is that just something that appears with the Blue Ocean? Or because I've not seen that before, but I've been using it quite a lot.
No, so this multi-branch thing, it was there with Pipeline, but with the Blue Ocean it makes it much more easier. As I said, I mean, so all you do is configure your source code control, it lists the thing, the repositories, and then the project, and then you select that, and that's it.
So will it query different branches that are already there, then, or do you have to tell it which ones?
No, it will automatically list all of it. So yeah. So this is the toolkit that we wrote. So we have download it, but so you can see just about here. It says my awesome toolkit, which it is hopefully will build and then publish to my VI package repository. So the build has gone through. And so the next is the publish step. Hurrah, green. Okay, so if I open my VI package manager now, so there you go, 1.00 is now 0.03, so that's your part of your continuous delivery process. So somebody who opens up VIPM the next time around will say that, will be notified that there is a new update to your package. And so just to look at the code behind it, what we've done. All we've got is a UTF call to the library, and then an LV build for the project, for the PPL, and VIP build again, and that's a shared library call. So it then becomes this simple, and then at the end of it, it's a VIP publish and the repository, and it then allows you to build your. So that's your continuous delivery done. Is that fairly straightforward? Do you think? You still unconvinced, or?
The problem is that our customer uses test to test non-directed code.
So I have a solution for that. So we have so last time when I was at another week, so I spoke to the product support engineer, and he has released a test stand JUnit conversion style sheet. So which then takes the test stand report and then converts into JUnit, and then so you can obviously call test stand sequences using a command line. I actually have a script. If you're interested, I can give it to you. And then again, the same thing happens inside Jenkins. So I just want to show you. So in this pipeline run, so you can see that so it's saying that there are 11 tests and all are passing. If there's a failure, then it will list all the failures, and you can then see what happens. And the artifacts, so because I archived the artifacts at the end, so in this case, my VIP file is listed here. And so if I go back to my presentation, so syntax, so what else is possible within the things? So there's an option options keyword, which allows you to disable concurrent builds, for example, or override index triggers and skip default checkout. So for example, by default, because it knows that the Jenkins file exists in the root, it checks out the rest of the files. If you don't want that to happen, you skip that and then do your own checkout. What I want to quickly show you is also a script generator. So in the so there's a script generator that ships with pipelines. I mean, and if you use that, it will give you the Groovy scripting for that. I mean, so this is a simple one. I mean, so if you want a one based on credentials or something like that, so there you go, check out. Then you can choose which source code control you're using. So in this case, I'll use my credentials and then go generate script. Then it will give you the script already for you, which can be used within your pipeline. So for you to use Groovy scripts, then you need to use the script keyword and then contain that code within that. So that's one caveat. One other thing I want to show you is if a build fails, for example, or you want to go back and then debug something, so you can look at a test run and then go. So there's a feature called replay. So if you click on replay, it will list all your Groovy code, and then you can make some changes and run it here. So it stops you from having to come into the source code control 100 times just to get something right. So this is a good. So I did not know about this for some time, and my check-ins were like about 20 of those with changed quote, double quote to single quote. Sorry.
You can only implement pipelines, or also this will be from shared libraries?
No, the shared libraries cannot be replayed like this. So, sorry?
Does that mean pipeline?
Yeah. So, switch back to the presentation. So environmental key variables, so parameters. So you can also trigger multiple builds. So if you've got a top level build, and then you can parameterize each of the builds to say that, okay, I have for my build to proceed, I need these parameters, for example. And so you can pass that as parameters from one to the other, and you can then say, okay, if I'm successful, trigger the next build. So you may have like 5 different PPLs or something that you need to build. So that can be done. Trigger. So trigger is either an upstream build, as I said just now. So it then upstream then allows you to trigger a next one with the right parameters in place. Poll SEM. So to poll this source code control at the frequency that you specify. Chrome. I don't particularly understand the syntax of Chrome, but when I need something, I Google it. But basically, it is timing. So for example, if you are running not in your production or a deployment branch, and you don't really want to push it to your say repository or staging environment, or you want to stage it differently based on the branch that you're running, you can use the when keyword and then say when branch is production, then push it here or something like that. So you can also customize what you want to do. And obviously when then can be combined with any of, all of, none, that kind of thing. So demo 2 and 3 are already done. Oh, sorry, that shouldn't be there. Tips and tricks. So the snippet generator I just showed you, that's pretty useful. It is your server port / pipeline syntax. Use replace SSA, and use the pipeline editor to build or create a skeleton code before you start off. All your global variables can be seen again in this link. Use an editor. So the keyword highlighting is pretty useful. I won't use the GitHub Atom editor, but IntelliJ IDEA apparently also recognizes Jenkins. Well, I've not checked by now. Gotchas. So some of the scripts that need to run in Jenkins, which people who already use Jenkins already know this. So you have to then provide it some you have to approve some of these scripts, so make sure that you check for those things. Case sensitive, so Jenkins file has to be Jenkins file with a small or lowercase f and not a, so that doesn't work. It doesn't get picked up as a Jenkins file, if you like. I guess I come from a Windows background, so it is, I think that should work, but for Linux people, like, what are you talking about? It shouldn't work. Anyway, string manipulation, so as I said, be aware of using single quotes and double quotes and how your environment of variables expand and use double slashes for paths, etc. Questions? I know I'm standing in between beer and you guys, so yeah, sorry.
Right. Very with me for a while because I think I would love to use continuous integration, but I think I'm missing a big picture. And so, just a few quick questions to clarify a few things. How frequently are you running build process? Is that with every commit?
Ideally, so like the guys from an said, so we have like smoke tests. Smoke tests is a limited set of tests that we run every time to give us some confidence that the code is okay. But then there's a nightly build, which is probably 8 hours or so sometimes.
Okay. So then, what kind of source version control are you using? Is that Git?
Bitbucket.
Bitbucket. Yeah, but it's Git, but should be
Mercurial.
Okay. So what is the trigger for the build?
So the trigger, as I said, can be either a time-based trigger.
Yeah, but you've got a source version control on the server, or where does it?
So ours is on the cloud. So as I said, Bitbucket and Git are integrated into Jenkins pipelines. So which means that any push then results in a notification to the Jenkins server, and then you can trigger a build straight away. Or you can then say, okay, I don't want you to trigger straight away because sometimes I commit something and I realize that I've not added a file or something like that. So I then commit again. The second time around is the right one. So we give it a delay of like 10, 15 minutes or so before a build is triggered. But then it then results in an email coming back to me saying that, okay, the unit tests have failed, go fix whatever.
Okay, just the last question. So where the Jenkins actually is that also in the cloud? You've got LabVIEW installed there, or?
No, Jenkins server is on is on a server somewhere. It could be,
like an internal server?
Yeah, or it could run on a cloud, no problem. But we've got agents which are separate, so that could have capabilities of building either LabVIEW or some others which would just do C# or something like that. So based on what agents are connected up and how you specified your labels or how you specified your agents, then it gets one of those.
Okay, I'm about that.
Sure.
Yeah. So when it goes to the last question, how do you manage multiple LabVIEW versions? You create different sort of virtual machines, for example, with an agent on each, a unique big system with multiple versions of that.
No, you don't have to. So if you just have an agent with multiple versions of it, you then specify, in one of the, so you specify the version of it, and then James's CLI tool makes sure that the present version is killed before the next one gets generated. So if you want to generate multiple, that's easy as well. But if you've got multiple agents, for example, they could then run in parallel. So you could go to, one with 2014, the other with 2016.
On different machines?
Yeah, on different machines, yes. One other thing that you can do is, so if you want to, if you're building on different machines, you can use a stash and unstash command. So you can stash in one of the agents and then unstash in another, and the server would then facilitate picking up that and then taking, so you don't have to manually copy over or something like that. Yeah, sorry.
So this is probably one of the questions to the NI guys around here that have a LabVIEW on different machines, so common license.
Okay. The licensing, so.
Last question.
So for different LabVIEW versions, you need different licensing, and it's really difficult to have multiple licenses. or a dedicated license for a LabVIEW build machine. So is there a way to mitigate that? I guess I know the answer, but
Yes, I know.
So last question.
yeah, so a dedicated license is required for a build machine, right? So because without that you can't. I mean, so in my case, I mean, I've got, I don't know, 5 seats or so. I mean, so I can dedicate one to the build machine or two to different build machines. I mean, but whereas people with one license, I mean, they may not be able to use this flexibility to.
So if this is a problem for you, come talk to me. We are working on a license specifically for build machines for guided for tools. But I want to talk about what you're trying to do and how you're trying to use it to make sure that we're solving the problem.
Yeah. Okay.
Let's maybe have a specific table on
So can I take the last question?
Your last question.
Yeah.
My question is about return on investment. How long have you, I mean, this takes some time to implement. Have you have a feeling for, have you any return on your investments? How long does it take?
So as James mentioned this morning, I mean, so it's more of, I mean, what you, so we're a small business, I mean, so we can't spend a long time making sure that 100% code coverage is there. But you then make an informed decision as to what you choose, as to how much test you write. But implementing this is not intensive at all. I would say it's a half-a-day process. I mean, so you install all the packages, make sure the Jenkins is running, and with the toolkits, you should be able to get up and running pretty quickly. And we've seen significant improvement in how we do things. I mean, especially because we don't have to skip stages. I mean, so I've only changed a small bit. I mean, so I won't run the analysis or run the UTF or something like that.